It's been a couple days since we did some stuff. So just to help us remember stuff, we talked about similar triangles. Specifically, triangles that are similar have 3 congruent angles. And Dalton, what did we say about those sides? Wait, what? The sides are 3, 2, come on, Trey, I heard you. Is that? Proportional. Sides are proportional. So if we have A, B, and C, and over here we have D, E, and F. So we've got angle, the same as that angle, 90 degree, 90 degree. This angle up here is the same as that angle down there. And so we can say something like side A over side C is proportional to side D over side F. And we could say lots of other things. We could say that A over B is equal to what class? D over E. Or we could say that B over C is equal to E over F. Or C over B is proportional to F over E. That the relationship from here to here is the same thing as the relationship from here to here. So what's really nice about that is if, let's say, you've got numbers over here, all right? Let's say you've got, I don't know, 6, 8, and 10. You've got numbers down there, and you know that this triangle down here, you have angles that are similar, and you've got a value here. Let's say that this is 12, and that's pretty much all you need. You don't need anything else. You can say that 6 over 10 is the same thing as a relationship as 12 over F. 6 over 10 is equal to 12 over F. And then y'all know how to cross multiply, right? Okay? And you can solve all sorts of information about that, okay? And so the key sort of to knowing all this is obviously to understand that mathematical relationship, but also you've got to have numbers over here. You've got to have numbers on that base triangle, okay? Or at least you need to know the pattern of the relationship. And last week, or not last week, 2 days ago, we discovered that there was one special triangle. That was the 45, 45, 90 triangle. And we determined that it always has the same pattern. And that pattern was whatever side you have on, or whatever length you have on this leg over here also is going to have the same because it's an isosceles right triangle. Does anybody have in their notes what's the length of the hypotenuse going to be in that situation? X times the square root of 2. Yep. So real quick, what I'm going to show you is that there is another special triangle. It's the 30, 60, 90 triangle. And so I'll draw that. Try to make it a little bit, it's less isosceles. So I'm going to put the 30 right there and the 60 right there because the 30 has to be across from the shorter of the 2 legs and the 60 across from the longer of the 2 legs. And what we're going to do right now is we're going to discover what that pattern is. I mean, I can tell you, but what's the fun in that, right? It's more helpful. This is not a freak out. You're going to see the proof. You're going to understand the proof. Okay? So I'm just going to say there's some number, whatever number it is, happens to be across from the 30. Okay? And that's about all I can do right now. You might say, oh, don't we know that the side across from the 60 is 2x? The answer is no. I can actually tell you that it's not that at all. But that's what students tend to think. They tend to say, oh, the sides are proportional to the relationship of the angles, and that is not the case. Okay? But what we can do is we can draw a reflected version of that triangle down here below it. So 30 degrees, 60 degrees right there. And so I'm making a completely congruent triangle here. So if this is completely congruent, sort of not the underside, not the below, not the other, what is it? The upside down triangle here, a little late. Okay, worked better 2 years ago, but that's okay. We got an X there, his mirror partner. Now we can start to do some interesting things. From top to bottom, what is that entire length? X plus X is 2X. Now let's zoom out here and kind of look at this big picture-wise. Preston, what type of a triangle am I looking at? This large triangle that they form together.
Looks like an equilateral.
Yeah, it looks like it. Is there a way that we know that it's equilateral? All the angles are the same. 60 degrees on this angle, 60 degrees here, 60 degrees there. Absolutely. Because I know that that is an equilateral triangle, I'll put this in purple so it's 2x. I know that this side is 2x. I know that this side is 2x. And if I wanted to, I could also say that, this side over here is 2x. So far, so good? Now I'm interested back on that original triangle. What is this leg, this question mark length? And I'm going to the side across from the 60, and I'm going to figure out that question mark length using good old Pythagorean theorem. Because we've got leg, x, leg of question, and hypotenuse of 2x. So I'll say x squared plus question mark squared equals, parentheses around it, 2x squared. I failed to mention this, part of the procedure class. If I write it down, you write it down. Otherwise you look bored and tired, and I feel like you're not playing along, because you're not. So, thank you, ladies, gentlemen. But yeah, piece of paper, every step along the way. It helps you track. Alright, so x squared plus question mark squared equals 2x squared is 2x times 2x, so that's 4x squared. I'm going to subtract an x squared from both sides. So question mark equals 4x squared minus x squared. Tell me out, class, what's 4x squared minus x squared? 3x squared. And I have question mark squared. How am I going to get rid of that squared on the question mark? Square root. That side. Square root this side. So question mark equals the square root of 3. I'll split it up using our property of radicals that we reviewed last week. Square root of 3 times the square root of x. So, square root of 3, what is the square root of x squared? X. So square root of 3 times x. Or we will rewrite it, x times the square root of 3. Alright, so here we go. This is our board of remembrance. How do we have it written? So, I'll make this so be our formula board, if I can make it. So 4590 is x root 2. 30, 60, 90. Across from the 30 is x. Across from the 90, so the hypotenuse, is 2x. And then across from the 60 is x root 3. So Brianna, do you see how this might be kind of confusing? Where we know that 60 is 2 times 30. And we know you might think that that 2x goes down here, right? But it does not. It does not. The 2x is across the hypotenuse. And you're like, why is it across the hypotenuse? Because of that. Because we flipped it over, we found that 2x is equal to the hypotenuse based on the fact that that's an equilateral triangle. Okay? So the 2x is on the hypotenuse, and the x root 3 is across from the 60. Okay? it messes with your mind a little bit because it's not, because it's, once again, you think it's double, but that's not so much. It's x over here and x root 3 across from the 60. Remember that, write it down, live it, love it, learn it. Okay, so what we're going to do today is we're going to solve some problems, but before I give you the handout, I want to solve one or two of these by hand. So we're going to kind of use that fact over there, that you've got similar triangles and the sides are proportional. Okay? So let's say I'm going about my business as, I don't know, an architect or something like that, and I've got a 10-foot beam right here. I know that this is a 45-degree angle right there, and this is a 45-degree angle right there. I need to know, how long this roof section is, right? Because that's the roof. We've got something kicking out to the left and something going up. And I want to figure out how far that is. And some of you are like, oh, I know it just like immediately. I know what that is. Anybody want to just shout out what they think they know the answer is? X root 2, but it's not x in this case, it's 10. So you might say, oh, it's 10 root 2. Okay, so some of y'all get it, this is not our class. In case you didn't, okay, let me show you the way that what's really kind of going on here. So we saw 45, 45, x, x root 2. Let's call this, I don't know, h for hypotenuse. What we could say is that 10 over h is equal to x over x root 2. I'm saying this side over this side is equal to this side over this side. Okay, does that make sense? It's just proportions, right? So like I said, if you have similar triangles, all the angles are the same, the sides are proportional. Do we have all the angles the same? Yep. So let's set up this proportion. So we have 10 over h equals x over x. So one thing we do is we have an x in the numerator, x in the denominator, everything's being multiplied. So I can replace those with 1s. So this is 1 over 1 times root 2. And then we'll just do our cross multiply here. 10 times the square root of 2 equals 1 times h. So 10 root 2 equals h. So like I said, some of you are like, yeah, duh, I saw that immediately. I saw that if you have a 10 right here, so I know that whatever's here, you have the same pattern over here. It's 10. It follows the x, and then whatever that x is, you just take it and you multiply it by the square root of 2, and that's your answer right up there. And I would say, yeah, that's exactly what you would do. But my job as math teacher is not just to point out to you the shortcuts, but also to show you alternate ways in case you don't see shortcuts like that, in case you can't see the pattern. What if I had a 6 right here? What would this side up here over here be? What would this right here be? 6 root 2. Y'all see the pattern? Okay. Yeah, it's not too bad. But what if, that's assuming, by the way, I had a 45, 45, 90 triangle. What if, so 45, 45. What if I had 15 right here? What's this over here going to be? You're right. He's saying you divide by the square root of 2. That may be obvious to you, it may not be. Okay? If it's not obvious to you, that's fine. My go-to answer every time is set up the proportion. I'm going to redraw that just a little bit like that. What if I've got a 15 right there with 45 and 45? And I'll call this, I don't know, A. Well, right beside it, I'm going to write the pattern triangle, x, x, x root 2. And we just set up a portion, 15 over A equals x root 2 over x. by a thumbs up, thumbs down, or thumbs middle, y'all tell me, communicate to me, what is your comfort level with proportions? Thumbs up being, I got them. Thumbs down mean I hate them. Thumbs sideways. Okay? Seeing a lot of thumbs up. And in an honors pre-calc class, I'd expect that proportions cross multiple, you should be thumbs up on that. If you're not, you can come talk to me during lunch A. I'll be in the robotics room. But x over x is 1. Then we just sort of cross multiply. 15 times 1 equals a times 1 times the square root of 2. And how do you solve for a? Divide by square root of 2. Divide by square root of 2. So a equals 15 divided by the square root of 2. Oh, we do have radical down there. But before we deal with that, everybody comfortable with that? Just dividing both sides by square root of 2? No big deal? Okay. And that also matches, Dalton, what your gut level feel was. You said normally when I know this, I'm going from this side to this side and multiplying by the square root of 2, and you kind of felt like, what if I'm going from that hypotenuse back to this side, it seems like I would divide by the square root of 2. And that was a correct intuition. Now, at this point, we would want to play the game, get rid of the radical down there. Robert, I saw you gasp. How are we going to deal with that root 2?
Multiply it by root 2 over root 2.
Multiply by root 2 over root 2. No big thing. Numerators multiply, so we just have 15 root 2. Denominator, root 2 times root 2 is 2. So 15 root 2 over 2. I would not expect anybody to be able to say, oh, that's 15. Oh, down here it's 15 root 2 over 2. No, that's a little bit much. And maybe eventually y'all can, why ever you thought like that, or students that go like that. But I could expect, some of you will be able to go 15 and say, oh, this is 15 over 2. But then plug in the algebra for that. Okay. While we're doing this, let's just go ahead and do a 30, 60, 90 problem. I'll draw them all in the same orientation right now, just since we're kind of getting started. So across from the 30, I'm going to write, I don't know, 5. And so I'll put the pattern triangle always next to it. Across from the 30, I'll put the x. Across from the 90, I'll put the 2x. And across from the 60, I'll put an x root 3. Now some of you might be like, got this, I know what it is. Anybody want to make a guess what's going to be over here on the hypotenuse? 10. See, okay, so good job. 10. What if you weren't sure? What if you just called that h? I don't know. Can anybody set up a proportion for me based on this pattern here?
H over 5 equals 2x over x.
H over 5 equals 2x over x. That looks good to me. X over x reduces to 1 over 1. And we multiply, this would be h times 1 equals 5 times 2. So h equals 10. But I know a lot of you were like, yeah, that's pretty obvious because the pattern is whatever's over here on the cross from 30, the hypotenuse is double that, right? So you're just like, that's 5, that must be 10. By that same logic, what would this side down here be? 5 times the square root of 3. Because whatever this side is, this side over here is the square root of 3 times that. If you weren't sure, what you could do is, let's say we call this b, you could say 5 over b equals x over x root 3. And just to reiterate, the reason why I'm showing you the proportional way is because the proportional way works. Proportional way works every single time. The proportional way can help you if you're not seeing that pattern immediately, okay? And the proportional way is not too difficult. X over x is 1. Cross multiply there. 5 times root 3 equals b times 1. And b times 1 is just b. So 5 root 3 equals b, which is what we get up there. Okay? The proportional way is also the preferred way because you're not always going to be given the side across from the 30. Some of the times, you're going to be given the side across from the hypotenuse, across from the 90, and sometimes you're going to be given, oh my gosh, heaven help us, the side across from the 60. And you're not always going to be able to just be like, boom, multiply by 2, multiply by 3, I'm done with the problem, hooray. So, I'll show you one of those, I guess, intermediate ones. Then we'll go with the hard variation, so to speak. There's 30. So I guess an intermediate one might be if I give you the hypotenuse. It's 20 where?
Like the x is 20, then you have 20 root 3.
Yep, x is 20, so you know there, it's going to be half. And you know that it was 20 because you know that it's got to be half. Yeah, 20 root 3. Okay, so I guess that's why it's intermediate, because it took you 1.5 seconds rather than just 1. Okay, so the hard version, I guess, might be if you're given the side across from the 60. Let's say I'll put a 15 right here. Okay, and we need to find the hypotenuse, which is h, and we need to find this side over here, which I'll call a.
So the a side is 15.
I said you probably would never be able to think like that. Okay, let us set up the proportion. Okay, so I always draw the triangle immediately next to it, or erase, so that I can do the little game. I can say 15 over a equals, and then I can say x root 3 over x. When did y'all learn proportions? Like, normally 7th or 8th grade, you're studying, okay, alright. So, when did you deal with, so you had this, like, and similar shapes normally kind of went along with it, right? So, if you have any younger brothers or sisters, you probably could teach this to them. If we could just get them to sign that up. Now, to get them to realize the next step, which what is always the next step once we have something like this? We cancel it out. So that's the next thing. So cancel, we got 1 over 1. But then at that point, they might be like, okay, I know what to do now. And you would say what? Butterfly, yeah, okay. 15 times 1 equals a times root 3. 15 times 1, we're just going to write it as there. Now then you'd have to talk to your algebra friend, okay, and ask, how do I get the a all by itself? And they would say what? Divide by root 3. Divide by root 3. So we have a equals 15 over root 3.
Multiply by root 3.
And then this is normally your algebra 2 friend you'd have to pull in, so it'd be kind of like a group thing here. And say I need to multiply that by root 3 over root 3 to rationalize the denominator. Though Ms. Hausler has been doing that stuff at the end of algebra 1. And we have 15 root 3 over root 3 times root 3.
You better simplify that.
Let's go 3.
Simplify it.
Oh, and then we've got a 15 over a 3. Absolutely, we can simplify that. So one more step. A equals 5 root 3. So,
But if you get it down to 5 root 3, does that mean that h equals 10 or does h equal 30?
ooh, follow-up question. So A equals
Well, it's still
5 times root 3. So we've already established that to go from this side to this side, we're going to multiply it by 2. Okay? So 5 root 3 times 2. Remember, with multiplication, you can reorder, it doesn't really matter, so we could write this as 5 times 2 times root 3. And so that would be 10 times root 3. I could have gotten that same result if I said 15 over h equals x root 3 over 2x. But I have found, and you will find as well, it's easier to find the 30 side first and then just multiply it by 2. Okay? I want to give you some problems that will look the same way that you're going to see them in Alex. Some of you have already completed this assignment. I don't know how, since I just got it. But anyway, just do the work as a table on this, I guess. I also will say Alex is going to try to trick you because they're going to sometimes put the 30 and the 60 in different locations. And when they do that, you just be smarter than Alex and redraw your triangle in the right orientation. Okay?
You could just do it, Dave.
I'm going to give you about 5 minutes to see if you can get problems 1 and 2 done. 5 minutes to get those first 2 problems done. If you do get them finished, make sure you agree as a table and wave at me. I'll come check your answers.
What I just did. Mr. Goddard turns off now?
No, leave it on.
Okay.
We need this. But I am going to need you to log into onto your computer so I can
Yeah.
project that. So here's what I did. I'm not giving that first. I'm just giving this the first 2. I think are good enough. You know, the front and back. That's pretty much something. You're gonna need the 7 minutes. That's your Google.
Get the times. That's important, right?
250?
Yeah.
That's 3 laps, right?
No, that's 2.5 laps.
Oh, I was thinking of 12,000 or 1,200 maybe.
You see? I don't want you guys to think of the others. Think of no. Go up here, hurt yourself, and then come back and do it. So if you guys train like that, trust me, you'll see improvement. But if you guys say, no, I always gonna do the last one. No, you're not gonna get that last one. God, gonna make her much more. See, you have to get that last one.
Fun. I don't know.
Go do the high spot after.
Make sure you agree on 1 and 2. Then
In the morning, right?
Yeah, yeah.
Need to be talking to each other. Okay, communicate on 1 and 2.
Go to warm up 1 lap, and then do it, and then
You guys talk to each other on 1 and 2.
Oh, we have to?
In fact, I'm not going to take back over in 5 minutes. I want you to just keep working. Call me over when you get 1 and 2 agreed on as a table, and I will check it.
Because they're both the same angle. So they will be the same size. Yeah, probably.
Sure, yeah, no, absolutely. Are you all in agreement?
Well, no, that's why.
Okay, that could be simplified. One more, two, let's see, introduce just a two. I'm in agreement with hers, but not yours. You can so this is 4 over 2 over 2, so 4 over 2 can reduce each of 2. You have an answer on one?
We agree.
You're in agreement?
That side's 2.
Alright,
3, 2.
move on to the first station, and let's all agree on 3, 4.
I think it's 2 root 2.
Okay.
3 on are you all alone? Or 3, 3. That's
Okay.
for that one?
So, are you good on drawing the proportions on these?
Yes.
Okay, you need to write these proportions, write the proportions. Look over the other pages.
I forgot what I was thinking.
There is a work assignment on this, yep, and we do, as you point out, we do a week from things to next Friday. So, it's called right triangle, trace triangle. You're in agreement?